thoughts and ideas. Arun Chhabra is working with the company 8tree, and he's going to do a presentation today on sustaining dominance and looking and exploring at how surface inspection is done today. Once again, we welcome your comments and feedback and questions if you want to take part, and welcome to Arun.
Thank you, Hannah. Appreciate it. Good afternoon, everybody. So, given the time of day and the fact that it's the penultimate day of the show, and that I'm competing with live country music down the aisle and free beer over here, I really appreciate you all taking the time and interest to sit in. As Hannah mentioned, my name is Arun Chhabra, and I'm with a company called 8tree. And we are a precision measurement company. That's our pedigree. We started out in the commercial aviation space about 10 years ago, and have brought our pedigree of an understanding of precision measurement to empower the operator, the line worker, and the maintainer. And our purpose of being here today, we were invited to speak under the auspices of the MOLS session, so the military aviation logistics and maintenance activities that are going on here at MRO Americas. And the thesis behind it was, given our experience in commercial aviation as we've seen it over the last several years with respect to surface inspection as it pertains to aircraft readiness, how does that, and in commercial space we talk about turnaround time, right? So making sure the airframe is in good shape, its reports are in place so that commercial traffic can continue. How does that translate when you look at the military sector, the Air Force? And that readiness, that turnaround time becomes a competitive advantage when you're looking at the arena of where the warfighters are, where they're defending the country. And ensuring that turnaround time is really a metric of fleet readiness. How do you make sure that they're ready to defend the country, the aircraft are ready where they're needed? And we thought we'd share sort of a little bit of our experiences from the commercial space to initiate a little bit of a dialogue after this regarding the military sector. There we go. So, before I proceed further, just a quick show of hands. How many of you are familiar with aircraft damage mapping or aircraft damage? Okay, so I see a couple of hands there. These images might be familiar. This is damage to an aircraft that's due to a variety of factors. In one case, it looks like it's a hailstorm that's really affected the entire airframe. In another case, there's the debris on the tarmac during landing or takeoff that's impacted the bottom side of the wings. And then on the top left here, you see GSE impact potentially, or a bird strike potentially on a leading edge. And the question then is, how is it done today? What is the, if you will, the state of the art for the last several decades in terms of how the industry maps damage? Do any of these two images seem familiar to anybody? Okay, so I thought so. So this is how it's done today. There's a human being with a straight edge ruler, a flashlight, and a dial tip micrometer, a dial gauge. And they diligently outline the dent and then attempt to measure it to quantify the size of the dent, and then use the digital micrometer to find what they hope is the deepest point. There are a lot of studies that have been done over the last few years about this approach. So in 2019, at the last ANC that was held at MRO Americas, there was a study done where all the participating teams were given aircraft panel with dents that were pre-identified, and they were tasked with measuring those dents. About 80 individuals across about 80 readings across 8 dents and across all those teams. And what they found was this. So let me take just a brief moment to explain what you're seeing on this graphic. This is a radial infographic, if you will, where every one of those, what appear to be circles, is a ½ inch in size demarcation. So it starts with ½ inch and goes all the way to 2.5 inches. So imagine that being the size potentially of measurement. What you see on the perimeter, the numbers, those are the number of operators, in this case looking at just a sample of one dent across 10 operators, 10 people, measuring that one dent. And you see operator number 1 got 1.5 or 1.25 inches for the size of the dent. Meanwhile, operator number 10 got 2.25 inches for the same dent. And further down, if you see operator number 2 got, for the same dent set, it's only 1/4 inch. So we're looking at just for a given fixed dent, we're looking at variability that goes anywhere from 1/4 inch to 2.25 inches. Now, in the real world setting, how long does it take to accomplish that? Based on those time studies that were done across 80 readings, 80 contestants 3 years ago, on average, using these manual methods, it was in excess of 6 minutes. But time is only one factor. The other one, the important one, is the inconsistency, right? And that inconsistency creates a lot of doubt. It requires clarification, consensus building, and that impacts the amount of time the aircraft is on the ground. Turnaround time, fleet readiness time, those are impacted by inaccuracy and consistency of measurement. So the question then comes back to, how can we improve on this decades-old status quo? And I'll just show you a brief 30-second video before we get into the details of this.
I'm the Chief Operating Officer at Chhabra Aerospace. Even for a small dent, it takes some time to generate the data with respect to the depth and the width.
Dent check is a tool that scans the surface and it detects surface deformations and it can display those in augmented reality.
Generates a report. It's efficient. It's accurate. I think it's the only device of its kind that's out there like that. It's as easy as taking a photo.
Okay. So that 30-second synopsis sort of highlights what I wanted to then lead into. So those same measurements that you saw on the last couple of slides, from the manual measurement with the depth gauge and the straight edge, 10 operators, 1 dent, that's the red jagged line that you see there. That green line you see is those same operators looking at the same dent using a precision measuring tool that operates with one button. They pointed at the dent, they pulled the trigger, and irrespective of experience level, because those 80 participants in that study, they span a broad scope of industry. They were from cargo, commercial, military, business aviation. They were from aviation schools. And they spread across the whole spectrum of skill levels. Some were still in school, some were fresh out of school, some had 30 years of experience. But you see the variability was all over the map. Irrespective of their experience level, they pick up a tool that's designed specifically for damage mapping, for dent mapping, and they pull a trigger pointing at the dent, and you see whether it's operator 1 or operator 10, their readings are very tight in terms of the consistency. But we said consistency is not the only thing, it's how long does it take to maintain that accuracy. And so there was a statistical study done after those close to 100 readings that were compiled 3 years ago. And remember that in excess of 6 minutes for manual measurements that we spoke about? Using a tool to accelerate their capabilities to do that, it took less than a minute. Now, just a moment to share a little bit about what that tool is that you saw in the video. It's an optical inspection tool designed from the ground up, purpose-built for aviation maintenance. Commercial aviation maintenance industry was the one that helped define. Your peers in this conference room were the ones that helped define how that tool should work, how heavy it should be, how much power supply it should have. Their opening thesis was, we need something that's handheld portable that will seamlessly transfer from the workshop to the hangar to an AOG situation. They didn't want it to be tethered to anything, they wanted it to just work. And in doing that, they also wanted to make sure it didn't give them data, it gave them answers. So, we take our precision measurement understanding and we implement that in a tool that's packaged with augmented reality, with built-in AI, so that the mechanic, the technician, or in the military setting, the maintainer, they immediately see the impact of that damage, the result, the quantified, actionable answer related to that damage, so they can go off and figure out, can this aircraft fly, or do we need to take some action to get it back in flight? And that, once again, immediately has a direct impact on fleet readiness. So the question comes to, okay, so this is all novel and new, and it was when we were developing it several years ago, and so where is it used in terms of building credibility and comfort across the industry? So we're fortunate enough now that this tool that was designed to empower the technician, the maintenance individual in an MRO or a tech ops organization, it was designed to empower them, and it's now being used by close to 4 dozen airlines, MROs, and OEMs across the commercial, business, and cargo aviation fields. There are a couple of allied air forces that have begun using it to maintain their fleets, as well as some defense contractors that are supporting the U.S. Air Force in terms of their MRO activities. Close to 150 systems are already being used on a daily basis, and the digital reports that are generated from them are submitted to the OEMs, where they're used to disposition deck damage on a daily basis. And so that's a little bit about the tool and how it's empowering the industry. The whole focus was here in terms of how that commercial impact that we've been able to drive over the last several years is directly relatable to the military and armed forces fleets, and that's an area that we're now increasing our focus on in terms of enabling the warfighter, supporting the Air Force, and just as we have seen adoption across allied air forces, the goal is to enable and empower our own U.S. Air Force and their MROs for that. The studies that I mentioned to you from 3 years ago that were done at AMC, an identical event, we were invited back to host a similar event this year. So if you haven't been to the AMC just down the aisle here, I'd recommend having a look there. There's some very exciting events and competitions that are going on, and very inspiring teams. Event number 2 is focused on dent mapping. And you'll see contestants using the traditional tools, and you'll see them and the struggle they go through in order to get to the results. And then you'll start seeing the variability right there as they draw it. Some will identify a dent to be this way, some will identify it to be this big, and we've seen today some have identified it to be a square. It's all over the map. And so driving that consistency is really a key initiative for us to enable the industry. So with that, I'll try to keep this short and sweet, and I'm happy to take any questions. Thank you. Yes, please.
How long does it take to set up and calibrate?
Good question. So it takes 30 seconds from the time you push the button on the tool to get it ready to use. After that, every 2 seconds, you have a dent map. That's for setup and use. For calibration, it's a once in a year calibration cycle that we recommend, and typically it takes a half a day.
Can it be used with a drone?
Yes, so we designed this initially based on the industry request to be a handheld portable tool. And as we were going through the OEM certification cycle several years ago, around 2015 timeframe, we started looking at where sort of the industry was thinking, and we saw this interest in automation and drones. So we took the initiative as a small startup to go off and survey the drone landscape. It was very crowded. Lots of players, hundreds of players, everyone wanting to get in. And we filtered that down to who are credible drone players that actually have an understanding of aviation. And we selected some early partners. We're drone agnostic as a company, but we do realize that there are some partners out there that are much more mature and much more credible across the industry than others. And we've been working with several of them over the years. The most mature of those activities actually hit a very significant milestone last year, where the French Air Force demonstrated a year-long study where they used a drone from one of our partners, a French company named Donegal, mounted with our dent check tool, but the payload was miniaturized to be drone ready. And the culmination of years of collaboration there, where they, over the course of a year, did repeatability studies, and they mapped a Rafale fighter jet 2D and 3D inspection in 1 hour. So the answer to your question, does it work on a drone? Yes. We have multiple initiatives with multiple credible partners, and as our customers, our existing customers, the airlines or MROs, guide us, if they have a preference for a drone company that we aren't already working with, then we actively go and engage with others. From our standpoint, a drone is a human being, a crawling robot, or a robotic automation cell. These are different, but all very powerful vehicles through which to deliver the instant analysis, damage mapping capability that we provide. Did I answer your questions?
Yes.
Okay.
Looking at it from a perspective of hard to reach areas. So instead of having somebody at the top of a fuselage on a large aircraft hanging with a harness, how long would it take for a drone to get up there and map it out and inspect it?
Absolutely. So, and the metric I've shared with you is that, so just like when we designed the tool, it was designed the industry asked to say, answer these problems of damage mapping for us, bring in consistency, but please, whatever you do, don't make us build a new hangar just to use that tool, right? And so we took that to heart, and what we did was understand their workflow. Their workflow consists of GVI, and when they find an anomaly or 5 anomalies, then they bring a tool to it. So we were a drop-in replacement for their existing manual tools. The drone implementation follows that same mentality. The drone 2D sweeps the whole aircraft, spots areas of concern, and then it swivels the gimbal to the 3D capability and maps those. And so, as I had mentioned, this whole tool, whether the handheld or automation concepts, are now being used across these sectors. And we're seeing increasing interest from leasing companies, aviation insurance companies, to also implement that in their operations or for their MROs. Thank you for the question.
Yeah, how you doing? It just seems like it works well when you have like individual dent, but how well does it work when you have like clusters like on the trailing edge above the flap, when you have damages that are real close to in proximity to each other?
Thank you for the question. So I'll give you a verbal answer, but a very compelling 2-second answer awaits you down the hallway at our booth, where we have sample hail damage panels, wing slats, that have scores of dents, perhaps hundreds of dents. And over years, listening to customers asking for, they asked us to make a single shot spot check tool. We did that. Over the years, the feedback was, can you cover larger areas and bring that digitization to mapping and reporting? Last year, a multi-year effort of creating that was released to the market, and it essentially allows you to create a panoramic auto-stitched image of multiple scans taken in sequence. And it automatically stitches it, so you as the operator don't have to worry about which scan came first or second. And it was actually used late last year, and this relates to an announcement that Panasonic Avionics issued yesterday. They're one of our partners in the services that we provide to the market, where there was a severe extreme hailstorm that impacted several aircraft in Roswell, New Mexico late last year. They used the Ardencheck tool to map each of these aircraft, 5 wide bodies. Each of these aircraft had in excess of 2,000 dents. The operators had told us that their expectation was manually, traditional methods, it takes them a couple of months per aircraft. The tool was brought in and service work was done, and within a matter of days, the entire 2,000 dent map and digital report was created and submitted, and the operator and the OEM were more than satisfied with it. So it actually, the value proposition in terms of time savings goes through the roof the more dents you have. Right? Good, thanks for the question.
Yeah, on your dent check tool, is it a must to contact the surface for the scanning, or can it be non-contact metrology? And also, and the follow-up is that can it be adjustable to the in terms of access and portability and access? Can the tool be scalable, adjustable to the region of the impacted region?
Okay, good question. Can you remind me of your first one? I remember the second one about surface.
Yeah, from the video, it shows that the tool must contact the touch the surface.
So it is. Thanks for the questions. And so it is actually non-contact optical inspection. It's a precision 3D scanner that we've spent years packaging in a technician-ready one-button operation. So our vision as a company is to deliver precision 3D optical measurement as simple as taking a photo. And that's how all of our tools work, with one button. The contact that you're seeing here on the video, where they're holding up the frame, the distance frame, is not for the purposes of the tool touching the surface. The tool is still several inches away from it. And when you trigger it, the structured light patterns shine on it, and the reflection is captured, and our algorithms provide you an instant go-no-go dent map. The reason for that distance frame touching the aircraft is very simple. If you remember my opening thesis, we wanted to create a tool that was a drop-in replacement for existing methods that was transparent to the current workflows. It just fit in. They didn't have to think about it. And so it's designed to take out the guesswork for the operator. Am I too close? Am I too far? It's the perfect working distance to deliver the precision and accuracy that we specify. Does that help clarify the first part of your question?
Yes.
Okay. And so the second question, if I understood it correctly, you were trying to understand, was it around can we adapt to any surface type, or was it about can we get into hard to reach areas?
Yeah, the hard to reach access area.
So just as you saw that distance frame, that was designed for that particular distance frame that our customers use for easy to reach areas. So the fuselage, aft, forward, any part of most of the aircraft, and also leading edges. There's a sort of a guide on it that allows you to rest it on a leading edge and get a precision measurement. There are certain hard to reach areas. Now we do have a standoff that we require to deliver that precision measurement. So it's about anywhere from 35 to 50 centimeters. Okay, and of course there's some margin of tolerance built into that. But if there's a need to get into a very tight spot, then potentially that might be an issue. But we also have handling accessories to enable ease of access to those. But that separation of about 50 centimeters is a requirement to deliver the accuracy of measurement that we specify. Have I answered your question?
Yes. And one last question.
Please.
Can you two see the subsurface or just the surface?
Great question. So our focus is surface inspection. We are not a subsurface technology, but we do make sure that our tool is interoperable and can accelerate your use of subsurface technologies. And a classic example of that is if you're familiar with the concept of corrosion blendout on aircraft surfaces, you would typically use a UT gauge. You draw a grid on the aircraft surface, you draw a parallel grid on a piece of paper, and then You take the probe one small grid at a time, and the technician would write in with a felt pen the measurement on a piece of paper. And it's prone to a lot of human error, and it's very, very time consuming. So what we did at the industry's request is we made sure that DentCheck, for example, has a direct interface to a UT gauge. So now, using our built-in augmented reality or AR capability, we project the grid pattern needed for the blend up. So there's no more fine drawing on the aircraft on a piece of paper. And as that UT gauge probe touches each of those grid points that are being projected, the numbers, the measurement readings that populate on the UT gauge automatically get projected by our tool in real time on the aircraft surface. And in the background, they're being recorded as a digital record immediately. So there's no note-taking, there's no human error, and it digitizes that process. So we're purely surface inspection, going back to your question, but we do interface to other technologies, other platforms, including subsurface inspection tools.
Example of the tool at your booth?
We've got a few examples of the tool at our booth. We've got a few examples of the tool where real-world users with no prior experience are using them at the AMC. So you don't have to take our word for it. I'd recommend you go and actually see the AMC contestants as well. But please do feel free to come by our booth. We're happy to show you other cases, corner cases, where the tool might be challenged and how it works over there. Thank you for your questions, James.
Do you have the ability to import your data into like a finite element tool?
So what form of data would you want to import into the finite element analysis tool?
Well, if you're taking the data that you actually get from the scans, determining your depth and all that stuff, and actually taking that picture and placing it within the, you got the panel itself on the screen, you can actually map it directly towards that. And then if you have multiple object damage, whatever, you can put that all on there at once and then run your FAA and see what level of stress and all that you have.
So we could make that. So let me explain a little bit about our again, back to our pedigree and our philosophy of why we started this journey 10 years ago. For the last 25, 30 years, we've been building high precision 3D scanning equipment. It takes highly trained people to understand how to program it, how to perform the scan, and then most importantly, how to decipher millions of points of 3D data into something that was part of your original problem statement, the answer you were looking for. And we took it upon ourselves to, try to get it out of that laboratory or R&D environment. And so by design, what we do is we don't spit out the point cloud. Even though it all exists under the hood, it's stored for every scan, we produce 2.2 million points of data. What we do is we go the last couple of miles of work, and we know what the industry that we're catering that tool to, what their criteria are for measurement, for, let's say, hypothetically, go, no-go criteria. We solve that, we take that data, and we process it so that when you as a tool user receive it, whether you're an airline, an MRO, a military operator, you click the button and it simply gives you the answer. Whether it's one dent, multiple dents, or extreme hail event dent damage. Now, if you were to say, Arun, we still want to see the point cloud data. Again, we designed it for technicians, so we don't necessarily lead with that. We don't even talk about point clouds to them because they just want an answer. However, if you do feel that a point cloud is very important to you, then we can show you how to gain access to it. It's all there in the background of the system.
So the go, no-go capability is all customer oriented in terms of how much damage, pitch, all that stuff.
Good question. So, yes, but I will clarify that just slightly. Please don't mistake us as being a custom tool developer. We focus on chronic application-specific problems. So it's sort of every tool we make, and we have a portfolio of 3D surface inspection tools. Every tool we make is customized to that chronic problem for the whole industry. Because usually what we've seen is the industry's requirements are they're pretty common, whether it's the military industry for aircraft damage mapping or commercial. And then on a case-by-case basis, if a customer says, hey, you're showing it in the results in Boeing format. I want to see it in Airbus format. That's